Hey, all. So we're going to do our section 2 notes for finding the square roots of non-perfect squares. So last day we did the square roots of perfect squares, and here are all our square roots of our perfect squares, our list that we made. And now we're going to use this list as a referral, so as a referent, to find the square roots of non-perfect squares. So to find the square root of root 20, so root 20, 20 isn't a perfect square. It does not appear on my list. So I need to use the square roots on either side of 20 to figure out, all right, what is my square root of 20 going to be around? So my square root of 20, so 20 will be in between these two perfect squares, 16 and 25. So my first step is to figure out what square roots, or sorry, what perfect squares 20 is in between. So 20 is in between 16 and 25, the two perfect squares of 16 and 25. So my first step is to look at the squares. And 20 is going to be, if I think about this as like a number line, about right here. Okay, so slightly closer to 16 than 25. Right, so I know that the square root of 16 is 4. I know that the square root of 25 is 5. So I know that the square root of 20 is going to be somewhere in between 4 and 5. So it's going to be 4 point something. All right, so taking a look at my roots. All right, so 4 point something is going to be the square root of 20. So it's going to be probably like 4.3 or 4.4. It's not going to be right in the middle because it's not right in the middle of 16 and 25, so it won't be 4.5. Okay, but it's going to be somewhat closer to 4. So to figure out which of those numbers it's going to be, we're going to round to nearest tenth-ish. So I'm going to take a look at my differences. So my third step, I'm going to take a look at the difference between my squares. So the difference between 16 and 20 is 4. So 20 minus 16 is 4. The difference between 25 and 20, 25 minus 20 is 5. Okay, so it's 4 is close to 16 and 5 is close to 20, 25. So to figure out what this decimal number is going to be, I'm going to take this 4 and I'm going to divide it by the difference between my two perfect squares. So 4 plus 5 is 9. So 4 divided by 9, if you were slightly unsure of that, I'm taking 4, I'm dividing it by 9. So 9 doesn't go into 4, but it does go into 40. And it'll go into 40 4 times. So I get 36, and we get a difference of 4. And then it's just going to be the same thing. So it'll be 4, 4, 4. So 4 repeating. So 4 over 9 is 0.4 repeating. And I would get 4.4-ish here if I'm rounding to the nearest tenth. Okay, so the square root of 20, so what times itself is going to give me 20? It's going to be about 4.4. Okay, so same thing, root 52. My first step, I need to see what the squares are on either side of 52. So what are the perfect squares on either side of 52? So 52 is going to be in between these two squares, so 49 and 64. So 52 is in between 49 and 64. And 52 will be closer to that 49, so we'll just draw it a little bit closer. It doesn't really matter, but we'll figure it out anyways. Okay, so let's take a look at what are my roots. So the square root of 49 is 7. The square root of 64 is 8. So 52 is going to be somewhere in between 7 and 8. So it'll be 7 point something. So let's figure out what that point is. Okay, so let's take a look at our differences. So the difference between 49 and 52, 52 minus 49 is 3, 64 minus 52 is 12. So my differences are 3 and 12. So I can see that I'm going to be closer to 7. So I'm going to be like 7.2 or 7.3 maybe even 7.1. And to see how far, so I take that 3, divide it by 3 plus 12 is 15. Oh, that's a nice fraction. So let's just reduce this. So 3 over 15 is going to be like 1 over 5. Okay, and 1 over 5 is about 0.5. Um, Once again, if you were unsure about that, so I have 1, I'm dividing it by 5. 5 goes into 1 no times. And then add a 0 there, so 5 goes into 10 2 times. And we get 10 and 0, so 0.2. Okay, so I should be expecting 7.2 to be the square root of 52. Okay, I'm going to give you some time to do root 13 yourself, so please pause this video and figure out what root 13 will be. Okay, so squares, roots, difference, pause. So figuring out the square root of 13, you should have first figured out, okay, what are your squares? So 9 and 16, 13 is in between there. Doing your roots of those, so the square root of 9 is 3, square root of 16 is 4, so the square root of 13 should be in between 3 and 4, so 3 point something. Next are differences, so difference between 9 and 13 is 4, difference between 13 and 16 is 3, so we do 4 divided by 7. And 4 divided by 7, just doing that quickly, will be 0.57-ish. So we go. So we should be to the nearest tenth, so 0.5. We get rounded up to like 0.6-ish. So 3.6 should be our about square root of 13. Right, and same thing for root 171. Give the video a pause, figure this out yourself. Okay, so for this one, 171 is in between the squares of 169 and 196. So the roots of those are 13 and 14. So I know root 171 is going to be about 13 point something. And taking a look at my differences, so 2 and 25. So 2 over 27. And now for this one, I would do something maybe a little bit different. So instead of like doing some quick division, I would, okay, 2 over 27 is really close to 2 over 25. And I know 2 over 25 is like, if I multiply both of these by 4, is going to be like 8 over 100, right? So I know that this 8 over 100 is like 0.08, 0.08, which is really close to 0.1. Okay, so for this, 13.1-ish is pretty close to the nearest tenth. And for our next example, we're going to combine that with some fractions. Okay, so finding the square root of 16 over 5. Well, I know from last day that I can look at the square roots of both of these two numbers separately. So look at the square root of 16 and the square root of 5. So the square root of 16 I know is 4. So 4 times 4 gives me 16. So I get 4. And the square root of 5. Okay, so 5 is in between the perfect squares of 4 and 9. So the square root of 4 is 2, the square root of 9 is 3, and 5 is much closer to 4 than 9. So this is probably going to be like 2.1-ish or 2.2-ish. So probably more around 2.2, right? And 4 divided by 2.2, sorry, I get approximately, so that's what those sign, like this wavy equal sign means. So approximately like 1.882-ish. Okay, so the square root of 16 over 5 is going to be about 1.82. Okay, same thing for b. So the square root of 19 over 6. Now, neither of these are perfect squares. So what I can do is think about them as like what perfect squares are they close to for this one? So 19 is close-ish to 16. So this is going to be like around root 16 instead of 19. And 6 is really close to 4. So you'll notice I'm going kind of down with both of these. So my fraction should be remaining somewhat equal. Okay, so 16 over 4. Now the square root of 16 is about is 4, sorry, and the square root of 4 is 2. So my answer should be somewhere around 2. So we're just approximating these ones. So we're not like finding it to like a nearest decimal place or anything. We're just approximating them. So these are two things, two ways we can we can approximate. Okay, so what perfect squares are they close to? Find the square roots of the ones that they're closest to if they're really close, and divide those to see what your answer is. So it's going to be about 2 for this one. Last example, determine a decimal that has a square root between 10 and 11. Okay, so if this is 10 and 11 as my roots, so the square of 10 is 100, so kind of going the opposite way. The square of 11 is 121. So a number which has a square root between 10 and 11 will be any number in between 100 and 121. So I could say 101 will have a square root between 10 and 11, 102, 103, blah, 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 120. So all of these numbers will. So pick one of those. I'm going to pick 113 because it's fun. So 113 is one example, but you can pick any number in there between 101 to 120. Okay, all right, you have your assignment. It is a worksheet. Happy mathing.